Okay, this next video is on standard deviation. In our last video, we looked at variance. Variance being the measure of spread, all right, the probability distribution about the mean. So how far are each of these values, on average, relative to their probability? How far are they away from the mean, right? And so we work this out by squaring the difference between each of the values and the average, which we call variance, and then multiplying each of those by the probabilities. And so for this probability distribution, we did that, and we got a value of 1.19. There's a bit of a weakness with variance though. Because you're squaring each of the differences, let me show you. Because you're squaring these values each time, what you end up doing is you end up, disconnecting this final value from the unit of measurement you first started off with. So for example, let's say these values here, right, our sample space, let's say that these are representing the number of workouts that you could do in a week. So 0 workouts, 1 workout in a week, 2, 3, and up to a maximum of 4 workouts in a week, right? This value here is not telling you, how many workouts you could do in a week. What's the it's just a basic measure of variance, right? So how far do each of these values in relation to their probability, how far are they away from the mean, right? The mean is this. This is a unit of measurement that is consistent with our data here. This is saying, on average, you are likely to do 2.1 workouts a week. This is just like it's a dry number. It doesn't have a context. There's no unit of measurement. So it's just like a raw number, 1.19. That's the measure of spread of each of these values away from that mean there. So what we can do is, instead of squaring, in addition to squaring, which gets us our variance, we can do the opposite. So take the square root of this number, square root it, and that'll get us our standard deviation. And then that can return us back to the unit of measurement. So, workouts per week, right? So let's do that and see what happens. So here's our new page. So like I said before, since the variance is determined by squaring the distance between our values and the mean. By the way, last video, I called this the wrong letter, right? This is mu. It is no longer in the same unit of measurement as the original random variable. By squaring the variance, it returns the variance back to the same unit of measurement, and we call this new value standard deviation. And here's the formula for it right here. It's pretty basic at this stage. There's another way of doing it, but just for now, in relation to variance, the standard deviation of our probability distribution is the square root of the variance of our probability distribution. Okay, so in this case, and we can use a new letter, sigma. So the standard deviation, I guess I can be a little bit more appropriate here. There we go. The standard deviation of our probability distribution is just the square root, in our previous example, of, what was it, 1.19? Yes, that was our variance. So we just take the square root. And if you do that, you get approximately 1.09. Now, because we took the square root, we are back in context. We have the unit of measurement. So what does this tell us? Well, it's roughly, 1.09 is a measure of the distance in the number of workouts per week, right? Of distance between each of these values and the mean, right? So we've put it back into context now. Our next video will be an example showing you a real life scenario.